Figures 1210 through 1211, attempting to inherit from the commission employee class into the base plus commission employee class. In this example, we're going to, for the first time, show you the inheritance syntax, and we're going to take a look at some compilation errors that are based on the way we chose explicitly to do the inheritance in this example, and on purpose, we are doing some of the coding a certain way to generate those error messages so that we can introduce in the next example a concept called protected data. And then we'll talk more about the software engineering of the hierarchy in general in another example as well. So here we have a new version of the base plus commission employee header file. Now, I just want to point out that we have the original commission employee class here from the first commission employee example. And again, just to reiterate, we have a constructor that receives 5 parameters. We have pairs of set and get member functions for all 5 pieces of data, and our earnings and print functions. And then we have our strings for the first name, last name, social security number, and then doubles for the gross sales and the commission rate. So this is the same commission employee class that we had in the previous example. Notice that the data is private in this class. So here we go to the base plus commission employee header file, and when you want to have a class that inherits from another class, you have to include the other class's definition so the compiler knows what's there that it can then inherit into this new class definition. Now notice how much smaller my base plus commission employee header file is than in the last example. That is because of line 12, where we say that class base plus commission employee inherits publicly from class commission employee. Now in C++, there can be 3 different keywords here: public, protected, or private. And in 99.9% of the cases, the keyword that you put there is going to be the keyword public. Protected and private inheritance affect how things are brought into your class. So public inheritance basically says that if you have any public members in the base class, they become public members in the derived class. If you have any protected members in the base class, and we're going to talk more about protected in the next example, those become protected members in the derived class. And any private members in the base class are hidden from the derived class. They do exist as part of a derived class object, but they are not visible to the derived class object's member functions without going through a call to a base class inherited member function. So again, with public inheritance, anything that's public in the base class is public in the derived class. So all of the commission employee header file's public member functions are going to be part of the derived class as well. We should mention, by the way, that constructors are not inherited, and that makes sense because constructors have to have the same name as their class. So actually destructors are not inherited either. So constructors and destructors are not inherited. So we have our public members are going to be public members of the derived class, protected members will become protected members of the derived class, and private members are always hidden in the derived class even though they exist as part of the new class definition. And by the way, many books get that specific issue wrong. A lot of folks would say that the private members of the base class are private in the derived class. That's not true, because if they were private in the derived class's own functions should be able to access the derived class's private data. So that is not the case. They are actually hidden from the derived class, but accessible via public and protected member functions that are inherited from the base class, and we'll talk more about that as we proceed through the next couple of examples. So notice that we don't say anything here about the set and get member functions for first name, last name, social security number, gross sales, or commission rate. That's because they are all inherited and have become part of this class's public interface. We do say something about earnings and print, and the reason we do that is we have to redefine these member functions for the purpose of class base plus commission employee, and the reason we need to do that is that the original versions of those that would be inherited from class commission employee are not fully appropriate for class base plus commission employee. The original earnings member function, for example, only calculates gross sales times commission rate and doesn't factor in the base salary. So actually, it turns out that class base plus commission employee has two earnings member functions: the one that it publicly inherits from class commission employee and the one that it defines in its own header file. And the one that's defined by this class is always the one that takes precedence. You have to explicitly say when you want to use the inherited version of the earnings function, and we will do that in a subsequent example. Same thing is true here for the print member function as well. So already you see a significant decrease in the number of lines of code in the header file. And similarly, if we take a look at the source code file, you can see a significant decrease here as well. So for example, here's the constructor for class base plus commission employee. And as you can see here, we still receive 6 parameters. And then we, at line 14, use the member initializer syntax to pass 5 of those over to the commission employee constructor. Now, you may recall when we talked a little bit about software engineering, when we were introducing how to build your own classes, that it's a good programming practice if you have another method in your class that does all or part of what a given method needs to do, that you should simply call that method. Well, in the case of a hierarchy of classes, the derived class constructor for base plus commission employee is required to call the base class constructor, in this case the one for class commission employee. And what the commission employee constructor is going to do is it's going to receive these 5 pieces of data, and it's going to use those 5 pieces of information to initialize the commission employee part of a base plus commission employee object. So remember, there's 5 pieces of data originally defined in class commission employee and inherited into class base plus commission employee and hidden within a base plus commission employee object. And then after those 5 pieces of data in memory is a 6th piece of data, which is the base salary that was added by class base plus commission employee. So in a way, you can view that set of 6 pieces of data in memory as 2 sub-objects: the 5 pieces that were inherited from class commission employee and the 6th piece that was added by class base plus commission employee. And one thing that confuses a lot of people when they're first getting into object-oriented programming, and in particular inheritance, is the difference between the classes and the objects of those classes. You have 2 physically separate classes, one called commission employee and one called base plus commission employee. In the commission employee class is where we defined the 5 pieces of data: first name, last name, social security number, gross sales, and commission rate. And when I create a base plus commission employee object, it contains all 5 of those pieces of data, plus the additional data that we defined in class base plus commission employee. So it's not that we have to create a separate commission employee object and a base plus commission employee object to make up what it means to be a base plus commission employee. That happens automatically. Those pieces are indeed inherited and used to create the base plus commission employee object. So the first 5 pieces of data are passed to the commission employee constructor, which already knows, by the way, how to initialize the first name, last name, social security number, gross sales, and commission rate. Then when that constructor returns, we call at line 16 set base salary to initialize the base salary piece of data inside of our base plus commission employee object. So by the time we get to line 17, all 6 pieces of data within a base plus commission employee object have been initialized. Now you'll notice that we do have our set and get member functions for the base salary, but you don't see anything here for the first name, last name, social security number, gross sales, or commission rate. Even though they're not physically present in the header file and source code file for base plus commission employee, they were inherited into this class and are part of this class too. So when you look at a class hierarchy, you need to not only study the header file and set of capabilities for the derived class, you need to study the header files and capabilities for all of the direct and indirect base classes of that class as well. And by doing so, what you're going to wind up with is a full picture, if you will, of what your class that you're using is capable of doing. And then finally, we have our earnings and print member functions, and you'll see we're getting some red squigglies indicating errors here, and I'll talk about that in a minute. In the earnings calculation, we're trying to say calculate base salary times the commission, or plus the commission, excuse me. And in the case of print, we're trying to output all of the data inside of our base plus commission employee object. Now, the reason we're getting these red squigglies is that we are attempting to access some pieces of data that were declared as private in the base class commission employees header file. So going back over there, you can see that we have private strings, first name, last name, and social security number, and private doubles, gross sales, and commission rate. Anything that you declare as private in a given class is only in the scope of that class, can only be directly manipulated within that class's member functions, or, as you learned previously, inside the friends of that friend functions of that class. So because these are private pieces of data here, we cannot see them inside of the member functions of the base plus commission employee class. So I cannot directly say commission rate and gross sales. I could have said get commission rate like this, and that's allowed because the get commission rate member function was a public member function of class commission employee, and was therefore inherited and became a public member function in class base plus commission employee as well. I purposely did not do that here so that I could show you if you try to access a base class's private data inside of a derived class, the derived class does not have direct access to that data. However, you can access that data if the base class provides appropriate set and get member functions that are inherited. And we will do that 2 examples from now, but first we're going to show you another way that we could have gotten access to these different pieces of data by using protected members, and we'll do that in just a moment. Before I do, let's try to compile this program just so that you can see the error messages that we're going to get when we try to use private data that was inherited from class commission employee. So if we take a look here, you can see at line 35 of the class base plus commission employees CPP file, we cannot access the commission rate here on line 35, and it says cannot access private member declared in class commission employee. So it's telling you explicitly, because this member was declared private in the base class, I can't access it directly here. And the same thing is true for gross sales, first name, last name, social security number, etc. So in the next example, we're going to show you how to fix this problem by using protected data in the base class, and then in the subsequent example, we will then go back to private data and show you how to properly software engineer your base plus commission employee class.